So question number 2 asks you for some properties again, but this time you don't get to see a picture like we did before. You just get to see the equation that that picture comes from. So there's a couple key things that we need to know about this equation. The first thing is that our direction is something that we can find by looking at that very first number. So in this case, the very first number out front is a 3, and it's a positive number. So if it's a positive number, we know that our direction is opening up. And if it's a negative number, it's opening down. So because it's 3, positive 3, our direction is up. Some people like to think of it as like, if you're a positive person, you'll be smiling, so that would be opening up. And if you're a negative person, you might be frowning, so that would be opening down in the shape of a frown. The vertex we can find by using these other 2 numbers. So the first number here is a 1, but when we pull it out of the brackets, you actually turn that into a positive 1. So really important to remember, even though this says -1, when you pull it out of the brackets, it becomes positive 1. So our vertex is 1, -9. The reason it's -9 is because -9 is not coming out of the brackets, so we don't need to change the sign. So our vertex in this case is the point 1, -9. Now our axis of symmetry, remember that the axis of symmetry was that fold line right down the middle. And what's important to remember is that the axis of symmetry actually goes right through the vertex. So our axis of symmetry is always an x equals line if we're facing up or down, because it's a straight line that's very vertical. And we know it's going to go right through our vertex. So it's going to go right through the point 1. So you can think of that as axis of symmetry, this x here, means you have to have x equals, and it also means that you're going to use the x coordinate of your vertex. Okay, so domain, remember we talked about domain is how far left and right. If you have a parabola that's a normal parabola, like the ones we're going to deal with in our course, your domain is always going to go all the way to the left and all the way to the right. So one way to write that is that x is in the real numbers, saying it's everything to the left absolutely negative and everything to the right very, very positive. Looking at the range, remember, we start at one point in the graph, which is our vertex, our lowest or our highest point, and we say where all the rest of the y's are going. So in our case, we know that our vertex, the lowest point, and it's lowest point because we're facing up, we're opening up, is -9. Which means that all of my y's are going to be bigger than or equal to -9. To get the y-intercept, remember that's where it crosses the y line, and the only thing we know about points that cross on that y line is that the x is going to be 0. If you look kind of back at the picture, any point that I had on the y line, no matter where I land, if I'm going to write the coordinates, it will be 0 for x. So this is the point 0,3, this is the point 0,2, this is the point 0,1, and so forth. So if I'm looking for the y-intercept and all I have is the equation, what I want to do is I want to write out the equation, but remembering that I know that x is 0. So I can write it out, y equals 3 times 0 minus 1 squared. That 0 is what the x turned into. Oh, sorry, there you go. Minus 9. Now I'm going to solve that. Y equals 3 times 0 minus 1 is -1, and -1 squared is 1. -1 times -1 is 1, because a negative times a negative is a positive. Okay, so now that I have y equals 3 minus 9, in other words, I have y equals -6. So I know that my y-intercept, or it crosses that y line at -6. Okay. Now the x-intercepts can be a little bit tricky, so I'm actually going to start a new video so you can see a new piece of paper just looking at how to get the x-intercepts.